Viewers, welcome to another mathematics lesson. My name is Khalid Jalo, and in today's lesson, we are going to look at nets of solids. And then we know that we have many solids, but then we're only going to concentrate on few of them in today's lesson. We are going to look at nets of a cylinder. We are going to look at nets of a cuboid, and we are going to look at nets of a rectangular based pyramid. These are the three solid shapes that we are going to look at today when it comes to their nets. In our previous lessons, we've talked about many solid shapes. We've talked about cubes. We've talked about cuboids. We've talked about cylinders. We've talked about cones. We've talked about spheres and so on. So in today's lesson, we want to concentrate on the nets of cylinders, cuboids, and rectangular based pyramids. Well, what brings about the idea of net of solid is just that solids are three-dimensional shapes, and then in order to form a three-dimensional shape, we'll have to bring together two-dimensional shapes in order to give us a three-dimensional shape. Like if you look at a cuboid, like for instance, this is a cuboid. What we know about cuboids, they are solid shapes that have six faces. They equally have edges and they equally have vertices. They have faces, they have edges, and they also have vertices. So what brings about the net of this cuboid? What plane shapes, that is two-dimensional shapes, can you put together in order to form a cuboid, which is a three-dimensional shape? Also, if you look at the case of a cylinder, this is an example of a cylinder. We said cylinders, they have two faces and they have one curved surface area. They have one curved surface area and two faces. So what two-dimensional shapes do we bring together in order to form this kind of shapes, that is a cylinder? Also, a rectangular based pyramid, also we are going to look at it. It is going to be of the same manner. We're going to look at what shapes do you bring together in order to form a rectangular based pyramid. So the plane shapes that you bring together is going to form, we are going to display them, and it's going to be the net of the solid in question. So today we look at cylinders, we look at cuboid, and then we look at rectangular based pyramid. Well, first we discuss nets. The nets are two-dimensional drawings that represent the surface area of three-dimensional shapes. They are two-dimensional drawings that represent the surface of a three-dimensional shape. Now, if you look at this one here, this shape here represents a cube. The shape here represents a cube. Now, the faces of each cube, the face of each cube is a two-dimensional shape. Now, when you now bring the faces together, that's the time you form a three-dimensional shape. Like for instance, we said cubes have how many faces? 1, 2, 3, 4, 5, 6 on this side. So cubes have 6 faces. So because we know that cubes, all the faces are equal, it means we need two-dimensional shape that have all their sides equal. So looking at this case, here is going to be one net of cube. You're going to have many nets depending on how you position them. So in this case, you realize that this is 1, 2, 3, 4, 5, 6. Now when you bring all these faces together, they form all the planes together, they form a solid shape. Now each plane here will represent one face, wherein they will form a solid shape. There is more than one way to draw a net for a cube. There is more than one way. If I want to draw it, I may have it this way. Let's say we have this, and all this they are equal, I can have another one here. And I will have another one here. They are all plane shapes that have all their sides equal. So when you fold it, you will form a cube rather. Now you can see this is a net of a cube. The one I drew here is a net of a cube, and the one given to us also is a net of a cube. So remember, the number of plane two-dimensional shapes that you will have is equal to what? Is equal to 6, because cubes have 6 faces, and because all the faces are equal, the two-dimensional shapes also, all the sides should be equal. So here we have 1, 2, 3, 4, 5, 6. That will represent the 6 faces. And here equally we have 1, 2, 3, 4, 5, 6, which is also going to represent the 6 faces. That is a general, an overview of what we are going to do today. Although we are not supposed to discuss cubes. I will leave that for another lesson. But just to give you a brief description of what we refer to as the nets of solid. Remember, our topic of discussion today is going to be centered on cylinders, cuboid, and rectangular based pyramid. Looking at the first one, which is a cylinder. Now, what do we need in order to form a cylinder? This is a milk tin. It says, if for instance we want to discard this milk tin, we have a sample here which is an oval tin. If you want to discard this, what are we going to have? Let's say if you open this part here, that is opening right here, and we split it, we'll have a shape that looks like this. That is, if you open here and split this side and split the other side, this is how it is. If you open here, split this side and split this other side, you'll have something that looks like that. Now this area here is like a circle, the one that is on top. That is one of it. And this other side is another one. That is the one that is on at the bottom. It's going to be like this. So you will see that we have one shape which forms the curved surface area, and we have two circles that form the flat faces. So to create a cylinder, you will need two cutouts of what? Of a circle and a cutout of a rectangle. You will need two cutouts of a circle and a cutout of a rectangle. The length of the rectangle should be equal to the circumference of the two circles. The length of the rectangle should be equal to the circumference of the two circles. Now, what we mean here is, when we split the tin and then it formed this rectangle, you see that the circle here was attached to the length of the rectangle. So technically, what that is telling us that the area round the circle, which is referred to as the circumference of the circle, is equal to the length of the rectangle, because that is where it was attached. So those two lengths should be equal. The circumference, that is the area round the circle, should be equal to the circumference, I meant to say the length of the rectangle, because that's where it is from. At the base also is the same. Since we split this, and you can see they are all attached together. When you split it and remove the circle, this will give us the circle. And when you split this other one, it's going to give us the rectangle. Since the circle is from the rectangle, that is the area, the distance around the circle, which forms the circumference of the circle, should be equal to the length of this rectangle. I hope you understand that. That is simply what we will need in order to form a cylinder. We will need a rectangle, and we will also need two cutouts of a circle. But they will be in such a way that the length of the rectangle is equal to the circumference of the circle. So the circles there will form the base, that is the flat faces of the cylinder, and the rectangle there will form the curved surface area. we have an example here. This is the rectangle, and then we need two circles that their circumference, that is the area around the circle, is equal to the length of the rectangle. Now we have this small circle, as you can see. We have this small circle here. The circumference of the circle is measured, and the circumference there is equal to the length of the rectangle. Now the width of the rectangle determines the height of the cylinder. The width of the rectangle, that is this side, determines the height of the cylinder. Later we will fold it and see what we are going to have. This is one of the circles that we need, and here is the other one that we need. So here also, the circumference of this small circle here, that is the cutout here, is equal to the length of the rectangle. So if we fold this perfectly, we are going to have what we call a cylinder. What do we need in order to form a cylinder? We need a rectangle and we need two circles in such a way that the circumference of the circle will be equal to the length of the rectangle, and the width of the rectangle forms the height of the cylinder. So let's try folding it and see. Well, this is what we will have. This is what we will have as the one face of the cylinder. Then the other one will be here, which is also going to form the other face of the cylinder. As you can see, the rectangle now forms the curved surface area. The rectangle forms the curved surface area. This is what we're going to have, and this is an example of a cylinder. It has two faces. That's one here and the other one is here, and it has one curved surface area. So as you can see, the length of the rectangle is equal to the circumference of the circle. The length of the rectangle is equal to the circumference of the circle. Here also we have the length of the rectangle is equal to the circumference of the circle. Now in order to form the net of a cylinder, this is what we have. When we split the curved surface area, this is what we are going to have. We are going to have a rectangle wherein the length of the rectangle is equal to the circumference of the circle. The height of the rectangle determines the width of the rectangle determines the height of the cylinder, and then the other circle also, its circumference is equal to the length of the rectangle. So when you fold this, we are going to have what we call a cylinder. When you fold this, we are going to have what we call a cylinder. So basically, whenever we are to have a cylinder, there are numerous ways to write or draw the net of a cylinder. There are numerous ways to do it. Like looking at the examples that we have here, we have a rectangle and we have two circles attached to it. Now remember, the length, that is from this point to this point, which is the length of the rectangle, is equal to from this point going around the circle. That is the circumference of the circle. Again, this other circle also we are considering the same thing. From this point to this point, which is the length of the rectangle, is equal to from this point on the circle going round the circle. That is, the circumference of the circle is equal to the length of the rectangle. Now this small length here, which is the same as what we have here, forms the height of the cylinder. Now if I am to represent this in this manner, well, it just happens that this circle is attached on this side to give us this shape. So if you want to form a cylinder out of this, you just fold it. You just fold it like that. You just fold it like this, and then you will see that this circle is what we had here, and this other one is what we had here, and the rectangle is what we have here as the curved surface. So that is how we have the net of a cylinder. Again, looking at this other one also, it is a net of a cylinder. and I think it is in this way. This is a perfect replica of it. We have the cylinder, we have one of the circles here, and we have the other circle here. So again, this, if you properly fold it, it is going to give you, if you properly fold it, it is going to give you a cylinder. If you properly fold it, it is going to give you a cylinder. In this case, we are going to fold it like that. This is what we are going to have, and this side will be covered like this. I hope you understand it. So again, it is a what? It is a cylinder. So the height of the width of the rectangle will form the height of the cylinder. The length of the rectangle will form the edge we have on the cylinder, which meets with the circle. So that is what we have on the cylinders. I think now henceforth we'll able to make nets of a cylinder. All what we need to consider is the fact that cylinders, in order to form it, you need a cutout of what? You need a cutout that is a triangle, a rectangle rather, with a length and a width. The width is the height of the cylinder, and then we need two circles. The circumference of the circle should be equal to the length of the cylinder, in such a way that you are going to attach the circles on the length of the rectangle in order to form a cylinder. We move on to the next one. The next one that we have is a cube, a cuboid rather. Next one we have is a cuboid. Now, how do we come up with the net of a cuboid? Let's try to draw a cuboid here, and then see if we can come up with the net. Now remember, we said cuboids, they have how many faces? They have 6 faces. So technically we need 6 faces or 6 two-dimensional shapes to put together in order to have a cuboid. Now this face here, that is this side here is one of the faces. If I'm going to open it now, I will have, let's say we have this. This is how the cylinder looks like. Now this side here is what we are going to have, let's say this way, if you open it flat, and then this other side, that is the face in front here, is going to be like this. So the base is what we are going to have there, and then this other side, which is here, is what we are going to have there. Then remember, we are left with 2 now. We are left with here and the back. Now this side is what we have there, that is this other side, and then the one on top is what we are going to have there. Now technically this is how the net of a cuboid should look. How many faces are there? We have 1, 2, 3, 4, 5, 6. In the previous lessons, we've learned that cuboids, they have 6 faces. Cuboids have 6 faces. Now let's look at the one that we have on the board. And if you open it, let's see how many faces or how will the net look like. Like this one that we have here. The base of the cuboid, if I'm going to use this one, the base of the cuboid, let's assume the base is here. This is the base, that is this side. Then this other side that is facing us is what we have here. Let's say we have that as this. And the other side, opposite to this one, which is on this side, is what we have here. Now as you can see, we've covered the base. That is the base. We've covered that. Also, we've covered this other face. And then we've covered the face at the back, that is this other side. Those are the 3 faces that we cover so far. So we are left with this side, the side opposite to it, and the one on top. That is this face, this other face, and the one on top. So this face here will be that one. that is this other face, and the one at the back, that is the one at the back there, will be this, which is what we have here. And the one on top now, the face that is on top here is this other face. So this is going to give us that face. So as you can see, this face and this face are equal. That is this other face and this other face, they are equal. This face and this face are also equal, which is here and here. And this face with this face are also equal, which is here and here. So that is what forms the cuboid. So again, we can have an example of the net of a cuboid. How many faces do we need? Since it has 6 faces, we will need 6 cutouts, and then we'll try to make sure that the opposite faces are equal to avoid overlapping. So if you look at this now, this is an example. It has how many faces? This is 1. This face is 1. We have here, this is the second one. Then we have here, which is the third one. Then we have the one on top, which is the fourth one. This side, the fifth one, and here we have the sixth one. Now when we fold this shape, what are we going to have? When we fold it, what are we going to have? We fold this side and fold this other side. What do we have? We have a cuboid. We are going to have a cuboid, because here we said cuboids, they have 6 faces and the opposite faces are equal. They have 12 edges and then also have 8 vertices. So that's what we have here. We have 1, 2, 3, 4, 5, 6. So this is what we refer to as a cuboid. So the net of a cuboid will look like this. Well, this is not the only net that you can have that will form a cuboid. So long the nets have 6 faces and the opposite faces are equal, if you fold it properly, it should give you a cuboid. Like if you look at these 2 examples here, well, this one is somehow a replica of this one. This is how it looks. When you fold this side, fold here and fold the one on top, fold the sides, then you will form what we call a box, which the box has the shape of a cuboid. Again, even this other one, when you fold it, although it happens that this side is attached here and this one is attached here, but when you fold it at the end of the day, it will form what we call a cuboid. So this is how the net of a cuboid look like. So you can try from your own end and see if you can make it. And then the basic information that you need is that it has 6 faces. So therefore you need to cut it in such a way that you'll have the opposite faces to be equal. And when you put them together and then the measurements are all correct, then you should have something like this. Now move on to the next one, which is the final one. And here we are looking at a rectangular based pyramid. A rectangular based pyramid. Now how do we form a rectangular based pyramid using 2-dimensional shapes in order to form a 3-dimensional shape in such a way that it is going to be a rectangular based pyramid? So a rectangular based pyramid is a 3-dimensional object with a rectangle for base and triangular faces corresponding to each side of the base rather. Like, in order to have a rectangular based pyramid, from the name we know that the base of the pyramid is a rectangle. That is from the name. We know that the base of the rectangle is a pyramid. The base of the pyramid is a rectangle. Now the faces that we have in order that correspond to the base of this rectangle, they are all triangles and they correspond to each other. Like, for instance, if I have this rectangle here, now in order to have its corresponding faces, they are all going to be triangles. Like this triangle on this side of the rectangle must be equal to this other triangle on the other side, that's on the opposite side of the pyramid. Again, this other side here, that is the triangle that we have here, should be equal to the triangle that we have here. Now all this should be done that in such a way that the sides of the triangles are what? Are equal. The sides of the triangles are equal, so that they will all meet at one point. Again, what we need to note in this case is that when dealing with a rectangular based pyramid, first of all, we say that the base of the pyramid must be rectangular. We have square based pyramid and others. But then in this case, we are looking at a rectangular based pyramid. So the base of the pyramid must be rectangular, like the case that we have here. If you look at it, this is a rectangle. It has a length and a width. That is a rectangle. Again, we have its the faces that are attached to the rectangle. You can see that the opposite faces are equal. This one and this one are all equal. And here, this side and this other side are also equal. And what is key in these four rectangles, although the opposite ones are equal, what is key there is to make sure that the length, that is the sides of the rectangle, they should be equal in order for them to form a particular shape. Like again, if you look at this one also, it's another small diagram that represents a rectangular based pyramid. Now look at it, this is the base. This is what forms the base. That is, this rectangle here forms the base. So if you look at this side and this side, these two triangles, they are equal, and these other two triangles are equal. But then what is important here is the length of these triangles all should be the same. Like we have an example here. Looking at this example, this is a rectangular based pyramid, the net of a rectangular based pyramid. The net of a rectangular based pyramid. Now, as I said earlier, the base of the pyramid is what? Is a rectangle. The base of the pyramid is a rectangle, just like what we have in these two cases. This side here is a rectangle, and this one also is a rectangle. That is this base. So the opposite sides now, that is this side and this side. These two sides now, they are also equal. That is this triangle and this other triangle. They are also equal, which forms this one and this other one, which is also this side in this case and this other side. That is these two triangles. They are also equal. Then finally, these other two sides. These other two sides now will be this one and this other one. They are the other two sides that we have. And also here we have this one here and this other. Those are the two-dimensional shapes that are attached corresponding to the rectangle that we have. So in order for us to have a rectangular based pyramid out of this shape, it's just that a matter of folding it in such a way that they will form a vertex on top. Now you see that if you fold this and you fold this other one here, what do you realize? You realize that they all meet at a point called the vertex. The length of the sides here should also be equal, so that they can all meet at one point. You see, the lengths are all equal. As you can see, the lengths are all equal. So in order to have this shape correctly, the net of this solid correctly, you must have to put all those things into consideration. First of all, you need to have what we call a rectangle. This is what you need first. Now when you have a rectangle, you need 4 triangles in such a way that the opposite sides are equal. The triangle here, these two triangles should be equal. That corresponds to the rectangle, and these two triangles also should be equal, and they also correspond to this length of the rectangle. Okay, if you look at the base of this triangle is equal to the width of the rectangle, and the base of this other triangle is equal to the length of the rectangle. So you can see these two triangles will be equal now because they all have the same base and the same length. Again, if you look at these two, they all form their base is equal to the width of the rectangle. Their bases are equal to the width of the rectangle. Now this is key. The length that forms the sides of the rectangle, apart from the sides of the triangle, apart from the side that is connected to the rectangle, should be equal. That is the length of the sides of the triangle, aside from the side that is connected to the rectangle, they should be equal. Like this length and this length should be equal, and all these lengths, they should all be equal, because this is done in such a way that when you fold it, they will all meet at a point we call the vertex. They will all meet at a point that we call the vertex. Now, looking at this one, you can see if you fold it, these two edges will be together. These two edges will equally be together, and then if you bring the fourth one now, these two edges will be together, and these other two edges will be together. So you'll see that they will form a vertex on top here, and that is why it is referred to as a pyramid. They will form a vertex here, and it's the basic reason why it is referred to as a pyramid. So what do we need in order to form a rectangular based pyramid? But as the name denotes, a rectangular based. We need a rectangular base. Aside from that, we look at the length of the rectangle. We should have two triangles that have the base of the length of the rectangle. That is one. Again, we need two other triangles, that is this one and this other one here, that have their base equal to the width of the rectangle. After having that, we measure the triangles in such a way that aside from their bases, the sides are of the same length. Aside from the bases that we talked about that are attached, that corresponds to the rectangle, the sides are equal. What I mean here is this side will be equal to this side, which is also equal to this other side, and equal to this side with this side, and also this side and this other side. If they are not equal, you realize that if you fold it, they will overlap, and that will defeat the purpose. So in order for us to have it correctly, we will have to make sure that all those sides are equal. The only sides that may not be equal is the one that are attached to the rectangle. In that case, the opposite ones are going to be equal. The bases of the opposite triangles are equal. So when you cut this properly and you fold it, you will have what we call a rectangular based pyramid. And that brings us to the end of the lesson. Remember, we've talked about three of them. We've talked about cylinders. We said in order to have a cylinder, what we need is we need a rectangle. We said we need a rectangle, and the width of the rectangle here forms the height of the cylinder. We said the length of the rectangle should be equal to the circumference of the circle, the cutout of the circle that we are going to use, so that if you fold it, it will be the same. And then we'll need two circles. We have a rectangle and two circles in such a way that the circumference of the circle is equal to the length of the rectangle. That's what we say about cylinders. When we move to cuboids, we said cuboids, they have how many faces? They have 6 faces, and the corresponding faces are equal. So if you have a cutout that has 6 faces and the corresponding faces are equal, and then you put it in such a way that it will be in this manner. You can have this in different ways. You can have it in different ways. These are all like simple ways that you can use to form the net of a cuboid. And the last one we just looked at is the rectangular based pyramid. And what is key here is the fact that the base of the pyramid is rectangular, and the length, that is the sides that correspond to the rectangle, they are all triangles, and then the base of the opposite triangles are equal to the width of the rectangle, and then these other two bases of these triangles are equal to the length of the rectangle. And then we also say that the lines that the sides of the triangles, apart from the one that are attached to the base of the triangle, should also be equal, so that they will all meet at a point called the vertex. So far, that is what we have in this lesson, and then you will have your homework in exercise 3.5 and 3.7 of the geometry worksheet. On that note, I thank you all for your attention.